Hi friends, in this episode of Random Talks, we will talk about Vedic Cosmology. You can consider this as a part 1. This will consist of many sections explaining multiple things. The inspiration for this was Makara Sankranti that happened recently. There was a WhatsApp forward which told that every 80 years Makara Sankranti shifts by a day, basically from 14 to 15 to 16th January, and then it keeps on going mathematically. That seems true that it can shift to February in 1200 years. So then I started thinking, how is it according to the Indian system? And then I realized the invariance of Makara Sankranti or any Sankranti every month, every Indian month, and then I started some sort of a comparison between the Western and the Indian systems, and how the Western systems say that the seasons change due to the tilt, change in the tilt of the earth, how the Uttarayan becomes Dakshinayan, and after a certain number of years. But then the Indian system doesn't say that. So I've referred to certain papers and videos by a PhD in Indian astrology and some other papers to understand this. So this whole thing will be, first of all, explaining the switch in Sankranti as per the Western calendar, then how it's invariant with respect to the Indian system, and then it talks about Uttarayan, Dakshinayan, what is northward, southward movement, and why, as per the Indian system, they are more or less invariant. The seasons are invariant because it's told that even in Ramayana, whatever is the rainy season that's told, that's the same that's happening even today, right? That thing. And then what is the pole star, and then finally something about Adhika Maasa, which is a kind of a related concept. Okay, so I will explain with some nice drawings and explanations. Srimati Ramanujaya Namaha. So it will be 5 minutes of each video. It will be a continuous series, so you can watch it accordingly. Thank you. So let's start with investigating the switch in Sankranti as explained by the English system or the Gregorian calendar. Now first let's see, this is the geocentric system I have taken. This is the earth, and then this is the sun revolving around the earth. So the time for one revolution of the sun, it takes 365 days. So basically from this point, if it has to rotate, revolve and then come back to this point, it takes 365 days plus 6 hours and 9 minutes. So there is a delay of 6 hours and 9 minutes every year. Now if you see, let us assume that Sankranti fell on January 14th. 14 means January 14th, 9 a.m. on some year. So the next year it will be delayed by 6 hours 9 minutes, which is, it will be 3 p.m. 9 minutes. Okay, so January 14th, 3 p.m. 9 minutes. Now let us also assume that just for the purpose of convention, if it falls after 6 p.m. on 14th, let us consider, if it's falling after sunset, then let us consider it being pushed into the next day, just for convention, because that is what Indians follow. Because this year, it was told that some people celebrated it on 14th, some said it is falling after sunset, so celebrated it on 15th. So next year, it would fall on January 14th, 9 p.m. 18 minutes. So I just put it as January 15th because it is after sunset on 14th. And the next year it would again fall 3 a.m. 27 minutes, another 6 hours 9 minutes if you add to the previous one, it will be 15th 3 a.m. 27 minutes. Now after 4 years there is a leap year. So due to the leap year falls after January 15th, so the day will again switch back to 14th. So on the 5th year, if you see, it will be January 14th again, but if you add 6 hours 9 minutes to this, it will be 9 a.m. 36 minutes. So if you see, on the first year it was January 14th 9 a.m. in the 5th year it is 9 a.m. 36 minutes. So the Makara Sankramana, or one revolution of the sun around the earth to enter the Makara Rashi, it got delayed by 36 minutes. Okay, what are Rashis? I will explain later. So based on that, if you see, after every 4 years, if there is a delay of 36 minutes or switch of the Makara Sankramana by 36 minutes, then after 40 years, it will be 360 minutes, which is basically a 6-hour switch. So you can see that the 9 a.m. thing after 5 years will be 3 p.m. and then after another cycle of 40 years or 80 years, it will be it will be moving to 6 p.m. beyond sunset. Now, so based on that, if you see here, this table shows that every 40 years there is a 6-hour switch, right? So basically the pattern is changing. 1969 to 72, it was January 14th, 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 15th. 2009 to 2012, 14, 14, 15, 15. 2049 to 2052, Jan 14th. So this 14 became 15 because maybe it was falling at 3 p.m. here. That 3 p.m. becomes 9 p.m. 9 minutes, right? As I just explained, 6 hours, right? Basically after 40 years. So 14, 15, 15, 15, the pattern became. This 2089 to 92, it became 15, 15, 15, 15. Now I put a star here between 2089 and 2101. If you see, there is not 40 years gap, but year 2100 is not a leap year, right? Because for it to be a leap year, a year should be divisible by both 100 and 400. So since there is no leap year here, so there is no extra day, so the Jan 15th thing got pushed to Jan 16th, the Makara Sankramana, and it will not be pulled back because there is no leap year here, so it became 16. 2125 to 2128, it became 16, 16, 17, 17. So 16 in 2125, 16 in 2126, 16th January in 2127, 17th January in 2128. So based on this, it says the English calendar says that after around 1200 years, Makara Sankranti will be pushed to February. And then it makes an incorrect statement saying that it will be pushed to February, so Makara Sankranti will come after Radha Saptami. Now that is wrong, right? Indian system is invariant with respect to Makara Sankramana, which is what I will explain in the next video. Let us now understand the Indian system of astrology and the movements. So here at the center I have the earth. This is a geocentric system, and then the sun on this circle, the orbit or the ecliptic. Now imagine that this whole thing is a wheel, a potter's wheel where you make pots. Imagine that the line connecting earth to sun is this red line, is a mark on this wheel or an indentation on this wheel. So as the wheel spins, that red line also moves. Okay, so there is no relative motion between the sun and the earth. So everything in the Indian system is explained as spinning around this particular axis, which is the pen of the earth. So the sun, the green ones that I have shown, the stars, everything is spinning. So this whole wheel is spinning, right? Now to explain the relative motion of the sun and the earth, what Bhagavatam says is, while this wheel is spinning, like while this red line is moving to this side, the sun, like an ant on a potter's wheel, A-N-T, ant, the sun is moving in the opposite direction slowly on the circumference of this wheel, right? As the wheel is revolving in one direction, the sun is walking slowly in the other direction on the circumference. That explains the relative motion of the sun with the earth, and that explains the revolution. And also, if you consider the earth as a ball at the center, the ball itself is spinning about its own axis. That explains the rotation. Now, you have seen that I have made 12 divisions of this orbit. 12 divisions, 30 degrees each. These 12 divisions are basically the 12 Raasis or the zodiac signs. That is, for example, Aries, Pisces, etc. Like Aries, Taurus, right? So, Mesha Rasi, Rishabha Rasi, etc. And then if you have seen, I have drawn some green stars around this orbit. They are actually far away from this orbit. In the Indian system, we have 27 stars that are important to the Indian system. Now here there are no 27 stars I have just drawn, but imagine it's 27. That is important to our system. Each star is further divided into 4 padas, which I will explain. So if you see here, the sun is revolving on this orbit due to the relative motion I explained. When the sun is between this point and this point, this sector of 30 degrees, right? Each is 30 degrees. You can see in the backdrop of the sun as seen from Earth, these three stars are there. So I have drawn a cone. This green line, this green line. In this cone, these stars are there. So these three stars are classified as belonging to this sector or this Rashi, right? So there are 12 Rashis that are defined by the 12 divisions of this circle, 12 sectors of this wheel, right? So these three stars are falling in this particular Rashi. So, and each star has 4 padas, as I said, right? So when you see, let us say the sun is here at this point. I've drawn 4 lines that go and meet the 4 ends of this star. So starting from here, 1, 2, 3, 4. So from the earth, if the sun is here, as the sun moves, it moves to the first pada, second pada, third pada, and the fourth pada of the star. So these stars, 4 parts are seen in the backdrop of the sun. So in summary, so the sun moves, as the sun moves, you will see it moving, each star in the backdrop of the sun. So here, this star is seen from the earth in the backdrop of sun. As the sun moves towards this side, this star is seen in the backdrop of the sun. So these 27 stars are divided into these 12 Rashis or zodiacs. So that is, each Rashi can have 2 or 2 plus stars. 27 divided by 12 is 2 point something, right? So, for example, one Rashi can have 4 padas of one star, 4 padas of next star, and 1 pada of the next star. Or it can have, let us say, 4 padas of one star, 4 padas of the other star, 2 stars. So, for example, in the Indian system, the Mesha Rasi, Aries, right? If this is Aries, it has the first 4 padas of Ashwini, and then the first 4 padas, all the 4 padas of Bharani, and the first pada of Kritika. Then the next Rashi, which is Taurus, has next 3 padas of Kritika, all 4 padas of Rohini, and then the first 2 padas of Mrigashira. So if you see, this is the Indian system, and as per the Indian system, I will explain the invariance of Makara Sankranti next. Alright, now let us understand the invariance of Makara Sankranti as per the Indian system. So we have seen Rashis and stars. So what is Makara Sankranti? So imagine that this sector is one Rashi, let us say it is Dhanur Rashi. This sector is Makara Rashi, right? So this is Makara Rashi, Capricorn, right? So the sun, let us say it is moving like this, right? So when the sun enters from one Rashi to another Rashi, that is called as Sankranti, and the sun takes around 30-31 days to move through each division, because sun takes 365 days, right, to complete one circle. 365 days, 6 hours, 9 minutes. So 365 or 360 divided by 12 is 30. So the sun takes around 30-31 days to move through each Rashi. As the sun switches, let us say, from one Rashi to other every month, as per the sun's movement as seen from earth, there is a Sankranti, or there is a change of the solar month. So if this sector is Dhanur Rashi, when the sun moves from Dhanur Rashi to Makara Rashi, it is called as Makara Sankranti. This point of switch from here to here is Makara Rashi. Okay, so as you can see in the Indian system, now in the English system, the sun might take 365 days, 6 hours, 9 minutes to, after 1 year, to take, to go from this point, complete one circle, and then come back here. And then as we discussed, in the English system, it can happen that this switch can switch from January 14th to 15th to 16th. And, in every 40 years, there is that change. And then it can move to February also. That's fine. But if you see in the Indian system, the completion or Makara Sankranti always happens when the sun switches from Dhanur Rashi to Makara Rashi, whatever time it might take, right, for that one revolution. So every year, Makara Sankramana or Makara Sankranti happens based on the switch from this sector to this sector only. So that is invariant, right, with respect to the Indian calendar. So our calendar is dependent on Earth, Sun, and now I've drawn Moon here, and then the stars. Okay. Now that particular, some of the people confuse you, as I said, saying that okay, if as per the English calendar the Sankranti switches from, let us say, January to February, it might come after Radha Saptami, but that is wrong. This is the fallacy where you are mixing two systems, right? What is Radha Saptami? Radha Saptami, it happens on Magha Shukla Saptami, that is in the lunar month of Magha, the 7th day, right? Now there is solar month, I explained to you. This is when the sun is moving from one sector to other. It is solar month. Now I have drawn the orbit of moon also. The orbit of moon is just, it's a zigzag orbit, but it makes just 5 degrees inclination with the blue orbit, that is the ecliptic. So more or less the moon is basically also revolving around the earth. Now what is lunar month? I will explain that in detail when I discuss Adhika Maasa, but you can see that a full moon occurs when the moon is opposite to the sun with the earth at the center. Okay, that is when the full moon happens. So when a full moon happens, you need to see that as seen from the earth, whichever of these sectors the moon is in, that sector, there is a star in that sector. Let us say this star is Makha star. So as seen from the earth on a full moon, if in the backdrop of moon, if you see the star Makha, then that is the Magha Masa, whichever month in which the full moon happens and is associated with a particular star. So on a full moon, if you see Makha star from the earth, that is Magha Masa. So again, the lunar month is also dependent on the movement of the sun only. Obviously, movement of sun and moon, right? So the moon has to be opposite to the sun with the earth at the center. So again, the Magha Masa or the lunar month is also dependent on sun's movement, and we are saying that the sun movement or moon movement, we are talking about the switch when they move from one sector to the other sector as seen from the earth. So Radha Saptami is also invariant. Makara Sankranti is also invariant, right? So Makara Sankranti will never switch to the other side of Radha Saptami. Okay. Now we will then in the next video understand the concept of Uttarayan and Dakshinayan, what is northward and southward movement, to understand the invariance of seasons with respect to the Indian system. Now let's understand the concept of Uttarayan and Dakshinayan, and then understand the seasons with respect to that. For convenience, I am switching to the solar centric system with the sun at the center and the earth revolving around this orbit, elliptic orbit, which is the ecliptic. And to understand Uttarayan and Dakshinayan, we need to understand that the earth's axis is tilted 23.5 degrees, I think approximately, with respect to the ecliptic or the orbit. So if you see here, this blue line is imagine this horizontal blue line is the ecliptic or the orbit of the earth around the sun, and then this inclined red line is basically the celestial equator, it's called as. So basically the arrows perpendicular to the celestial equator are nothing but the earth's axis. So if the earth is here, then this is the earth's axis. If the earth is here, that is the earth's axis. Same thing I have shown here. The earth is here, so its axis is tilted. Imagine this is a 3D thing, right? Basically, so you have to imagine that the earth is like this. So this line actually is like this, right? And then here the earth's axis is like this. Okay. So this point is called as summer solstice. This is equinox, autumnal equinox, winter solstice, and vernal equinox. Okay, just 4 points. As you can see, the earth is, as it's moving around the sun, it is basically moving like this. So since if you see here, the earth's tilt is not changing. I mean, right? That's a different concept. Change of tilt of earth. We'll cover that in the next section. But the Earth's tilt is not changing, but if you see on this side, when the Earth is to the left side of the Sun, it is pointing towards the Sun. So a point on the northern hemisphere is closer to the Sun as compared to when the Earth is on the right side of the Sun, wherein the Earth's axis is tilting away from the Sun. So a point on the northern hemisphere is slightly far away. So X is lesser than Y. This is what causes summers and winters. So here the point is closer, so there is summer here. The same point, at the same point there is winter at this point of time. So that is explaining summer and winter, and the rains, etc., and the autumn, the rains, etc., occur somewhere here. Now these 2 points are called as equinoxes, which I will explain later. Here the Sun is exactly above the equator of the Earth. They are called as equinoxes. Now as you see here, I have called this as Dakshinayan, this half of the movement around the orbit, and the upper half as Uttarayan. So if you see here on the left hand side, the Earth is pointing towards the Sun, but with the same tilt as it moves towards this side, it is pointing away from the Sun. So imagine that my mobile phone is the Earth, okay? So I have placed the mobile phone inclined to this whiteboard below, okay? Such that the top of part of the mobile is closer to the Sun, okay? Now I will change the tilt of the mobile such that when it goes to the other side of the Sun, the tilt is pointing away from the Sun. So as you can see, it appears as the Sun is moving down, right? So the tilt is relative to the Sun. It is pointing to the Sun here. It is pointing away from the Sun here. So as the Earth moves from the left to the right of the Sun, it appears as if the tilt which was facing towards the Sun is pointing away from the Sun. So it appears as if from a point on the Earth, the Sun is moving from top to down. So the downward movement of the Sun is Dakshinayan. Similarly, when from here to here, it appears as if, okay, the Sun is moving in the upward direction, because the tilt from here to here relative to the Sun, it's basically here it is away from the Sun, it becomes towards the Sun. So as the Earth moves from here to here, the Sun, it basically appears as if the Sun is moving upwards when seen from, let us say, this blue point on the Earth. So this is Uttarayan and Dakshinayan. Okay. Now the English system says that this tilt of the Earth changes, and because of it, the Uttarayan and Dakshinayan change, which we will cover in the next video, and how is it with respect to the Sun. Let us understand what the Western system says about the change of Earth's tilt. So, as per the what they say is that, let us say this is the tilt of the Earth, right? So let us say this is the tilt. So in around 27,000 years, this axis, the end of the axis, let us say the Earth is here at this point. This is Earth. So this is the tilt of the Earth with respect to this point, right? This let us say is the again, this is this blue line which is normal to the ecliptic. So the Earth is tilted like this. So the end point of this axis, it basically, there is no end point, but for imagination, imagine that one end of this axis is moving around this circle. So the Earth's axis changes its tilt with the locus around this circle, and it takes 27,000 years for the Earth axis to go from this point to this point and back. So in 27,000 divided by 2, which is approximately 13,500 years, the axis will move around this circle like this, and then it will be here. Okay, so you can imagine that it is like this, right? If you imagine this particular pen here, right? So it is basically here, and then it is, the axis is changing, the tilt is changing. So the top point of this pen is moving in a circle. So based on that, what they say is in around 13,000 years or so, or 13,500 years, at this same point, the Earth's axis will, rather than be pointing this side, it will point this side, and symmetrically it will point in this direction here. So after around 10,000 or 13,000 years, at this point of the summer solstice, the Earth's axis will switch from here to here, right? So basically the green lines will be the new axis. After 13,000 years, note that the tilt doesn't just change every year, it keeps slowly changing, and after around 10,000 years or 13,000 years, from here the axis switches here. So whatever was summer here now becomes winter. Whatever was winter here now becomes summer. So they say that the Uttarayan becomes Dakshinayan and Dakshinayan becomes Uttarayan. There is a switch. The summer and the winter switch 6 months apart after these many years. Now the Indian system doesn't accept that. As I told in the introduction of the video, it has been shown and proven that from the time of Ramayana to now, the description of the seasons is more or less same, more or less invariant. And how is it invariant according to the Indian system? We will discuss next in the next video. Now look at what the Indian system says about the change in Uttarayan and Dakshinayan. So, Indian system also agrees that the Earth's tilt changes, but it is not like the Earth's axis is making a full circle. It is a different thing. So to explain that, first again I will take a geocentric system. Simple thing here, there is Earth at the center, the blue one is the orbit, and then the Sun is moving in an inclined orbit. That is basically, if the Earth's tilt, you are actually going by geocentric system, then that becomes the Sun's tilt. Okay, so the Sun is making rounds about the Earth. So this is what you are seeing here. Okay, now you need to understand the concept of equinoxes. So these 2 points of intersection of this blue orbit and blue circle and the green circle are nothing but the equinoxes. I told you that when it's equinox, when the Sun is at this point or this point, it is above the equator of the Earth. So as you can see here, this blue one is the Earth's orbit or the ecliptic, and you can consider this green one as the celestial equator. So when they both intersect, when the Sun, let us say, so basically the Sun is going like this and then it is going like this. So whenever the Sun is at this point, it is in the plane of the blue line. So when the Sun is here or here, it is in the plane of the ecliptic. And that is when exactly the Sun is above the equator. If you consider this Earth as a ball, the Sun is above the eclipse. So these two are the equinoxes, and then 90 degrees apart, these are the solstices as we have seen. So this is where the switch, the solstices, from here it becomes Dakshinayan as we have seen, from here it becomes Uttarayan back to the solstice, and the equinoxes are kind of 90 degrees out of phase with the solstices. Having said that, what the Indian system says is that the Earth's axis changes its tilt, but it goes about an equilibrium tilt point. It goes 27 degrees to the right, back to the center, to the equilibrium tilt position, then 27 degrees to the left, and then back to the equilibrium tilt position. Now this 27 degrees is not the degrees of the tilt of the Earth's axis, but it is the degrees of the zodiac. So as you can see here, P0 is Pisces 0, A0 is Aries 0. So P0 to P30, P30 or A0 is nothing but this particular sector of 30 degrees. P30 is same as Aries 0. Aries 0, Aries 30. Aries 0, Aries 27. So what it says is that the Earth's tilt changes to and fro about an equilibrium position. That equilibrium position is Aries 0. About this equilibrium position, the Earth's tilt changes such that if the equinox, the vernal equinox, which is basically this intersection point here, if that equinox can change either to by 27 degrees, it can move on the ecliptic, that equinox point of equinox can change to A27, or it can change to P3, 27 degrees to the left of A0, or P30, or 27 degrees to the right of A0 or P30. So that is what is explained here, right? Go to the right, center, left and center. This whole circle of to and fro motion, it's basically, you can think of a balance, right? Mathematically speaking, if you model it. This whole tilt to and fro about the equilibrium position takes around 7,200 years. It is told in the Surya Siddhanta that in one Mahayuga, which is around 43 lakhs years or something approximately, correct me, and this tilt, this to and fro motion happens 600 times. So that whole Mahayuga time, Mahayuga is 4 yugas, if you divide it by 600, you will get 7,200 years. So from here, 1800 years it goes to the right, 1800 to center, 1800 to the left, and then 1800 back to the center. So 1800, the same is explained here. Now imagine that this blue line is the ecliptic, and then the equilibrium tilt position of the Earth, which is the green line. So that is this green circle. If you see, the green circle or the celestial equator is intersecting the ecliptic here at A0 and another point here diametrically opposite. So A0 is your Aries 0, which is the equinox when the Earth's tilt is such that this green line is the celestial equator, right? So perpendicular to the celestial equator, if you draw a line, that will be the Earth's axis. Now, the Earth's tilt, if it is changes to the black line here, from the green line, which is the equilibrium line, it can change to the black line. When it changes to the black line, that is basically, this is the side view of this. So now your celestial equator will be the black circle which intersects the blue circle, which is the ecliptic at A27. Similarly, when the Earth tilts from black back to the center, which is the green line, and to the red line, now if the celestial equator is the red line, then this is the celestial equator which intersects the celestial circle which intersects the blue line at P3. So what the Indian system is saying is that in the tilt of the Earth's axis is such that the equinox changes, the point of intersection between the celestial equator and the ecliptic changes from A0 to A27, Aries 0 to A27, back to Aries 0 and to Pisces 3, right? So I will show this same thing. It need not be that the Earth's axis has to make a 360 degree thing as the English people say. I will explain the same thing through a movement of two bangles, right? So let us take, these are the two bangles, okay? Now imagine that I take this bangle. This one is your ecliptic, and this bangle here is your celestial equator. So now you can see that the Earth's tilt or the celestial equator can change from the red to the equilibrium green to the green line back to the equilibrium. So it is basically like a balance, it's tilting, right, about this equilibrium position. So left, center, right, center, left and center. So that is what has been explained in the Indian system, that your vernal equinoxes really don't shift so much. They just shift by 27 degrees. So if your equinox was somewhere in March or something like that, right, it can either come slightly before that or it can come slightly later than that. And going by the same concept, we have seen that if the equinoxes change, let us take this circle, right, this is the ecliptic, right? So let us say that this was your winter solstice and this was your this was your summer solstice, winter solstice, and this is your vernal equinox, and this is your autumnal equinox. So if the equinox, let us say, changes from here to here by 27 degrees to Pisces 0, from Aries 0 to Pisces 0, this solstice changes from here to here. Similarly, this it can change from here to here, and this can change from here to here. And if this equinox is changing towards this side, then this point will occur here. The point of inflection when the sun starts moving, it was moving in the northward direction and then moves in the southward direction, that just changes. So, your Uttarayan can either start here when Earth is in the equilibrium position of tilt, or the Uttarayan can start here, or it can start here. So, 1800 years from this point, the Uttarayan can happen here. After 1800 years, again the Uttarayan will happen at this point of time. And after another 1800 years, the Uttarayan will happen at this point of time. After another 1800 years, Uttarayan will happen at this point of time. Now let us imagine that this is Earth at the center and this Sun is here. Right? Sun is here. So, if let us say that this is your, let us say that this is Dhanur Rashi. This is the sector corresponding to Dhanur Rashi. Now, you are shifting into the Makara Rashi. Right? So, you are shifting into this Makara Rashi. Let us say the Makara Rashi is here. So, from Dhanur Rashi to Makara Rashi, this is Makara Sankramana here. Okay. The Makara Sankramana, remember, it is basically happening here. And then your Uttarayan can shift from to this point or this point. So, the Uttarayan can occur slightly before the Makara Sankramana based on the change in Earth tilt. And then in 1800 years, the Uttarayan can again match the Makara Sankramana. And then in another 1800 years, the Uttarayan can go slightly ahead of the Makara Sankramana. So, the switch in the zodiac sign based on the sun's movement is always happening at this point of time. As we have seen, that is invariant. Sankranti, Makara Sankranti is invariant, or any Sankranti is invariant. But the Uttarayan can slightly, the downward or the upward movement of the sun, in this case the upward movement of sun can happen after this point, or it can happen after this point, or it can happen after this point. And that difference is in 1800 years, this changes. So 1800 years before, if it was happening here, the switch from downward movement to upward movement, it can happen here after 1800 years, right? After 1800 years here, after 1800 years again here and here. So this is what the Indian system says. So now you can see that the seasons can slightly only vary. So if the Uttarayan is starting here, your autumnal equinox can happen here, and then the Uttarayan ends here and the Dakshinayan starts here. If the Uttarayan is starting here, then your autumnal equinox will be here, and then your Dakshinayan will start from this point. If the Uttarayan is basically starting, let us say, here, then your autumnal equinox can be somewhere here, your vernal equinox can be somewhere there. So basically, the rainy seasons or even your summer and winter are not changing a lot as per the Indian calendar, remember. Okay, and then more importantly, the intensity of the heat of a summer or winter can change because of the change in the tilt of the Earth's axis with respect to the sun. But the summer will not become diametrically opposite. It will not come in winter, or the winter will not come diametrically opposite in summer, as seen in the Indian calendar. That is, the Uttarayan will not suddenly go and switch to Dakshinayan as it was mentioned in the English system. Let us also look at quickly a related concept of the pole star based on the Indian system of the to and fro motion of the change in the tilts of the Earth's axis. All of these concepts and details I have referred to multiple papers and then best explained in a video by Dr. Jayashree Sarnathan, who is a PhD in astrology. You can refer to that. The Vedic concept of the change in equinoxes and the pole star. You can refer to that. As you can see here again, I am just representing the previous section. So the green one, if you consider as the neutral position of the Earth's tilt, about that the Earth can switch to the red or the black, and this whole cycle takes 7,200 years. Green to black in 1800, black to green in 1800 again, green to red in 1800, and red to back to green in 1800. The same thing is represented here. Imagine that this is Earth, and then the equilibrium position of the Earth's axis is basically like this. So in the Indian cosmology, it is told, Vedic cosmology, that there is a mountain called Meru on Earth, and basically the axis of that mountain, if you imagine that mountain to be a cone, that is the axis of the mountain is basically pointing towards the pole stars. So this is one star. Now this constellation that I have drawn here is Ursa Minor. It's like a bucket here with 4 stars and then another 3 stars here. And the tail of this star is what is called as Dhruva Nakshatra, or the pole star. So from the equilibrium position, when the Earth axis tilts like this, the axis through the Meru is pointing to this particular star called as Polaris, which is considered as Dhruva Nakshatra. I'm not very sure. This is again an equation made by Polaris and Dhruva Nakshatra by perhaps, but that could be true. So, and then when the Earth's tilt again goes back to the center, it is pointing to this nakshatra, which is, I think, Agni or something like that. And on the left hand side, when the Earth's axis tilts to this side, it points to this nakshatra, which is Indra or something. So the axis goes from green to black in 1800 years, center back to green in 1800, back to red pointing to this star, back to center, again back to right when it points to the Polaris star. This whole cycle from green here, and back to green takes 7,200 years. And it is told that every 7,200 years, when the axis comes to the center and starts the onward movement, if this is the Agni Nakshatra or something, one of these papers explains that there was a fire accident kind of a thing, or a fire hazard on Earth. Now I don't know whether that has to do anything with the dinosaurs getting extinct due to a meteor hitting the Earth. Could be, could not be. But it is told, it is kind of, they surmise that this is the nakshatra corresponding to fire, and when the axis reaches this point, and before it goes in the forward motion and comes back, such kind of events have been found to occur. Now as you see, what is Polaris? When the axis is pointing like this, if this is the Dhruva Nakshatra, basically everything in the system, in the geocentric system, is spinning about this axis, as we have seen in the previous section. So this point, this Polaris star itself it will always be on the axis, right? So as seen from the Earth, the other stars, the sun, the moon, everything will be revolving about this axis, this black axis, but the Polaris will remain there, right? So that kind of matches with what we tell, that this Dhruva Nakshatram is basically the star of Dhruva, which never changes its position in the sky as seen from the Earth. And whether this is that same thing, whether it is always is invariant, or as we discussed in, it kind of keeps switching, that is a point of discussion or debate for a later day. But the concept of pole star is basically a star on the axis of the Earth. Let us finally understand a related concept called as Adhika Maasa. For this, we just need to revisit the concept of the solar and lunar months. But before that, I'll just explain when does a full moon occur, just as a revision. So if you see, this is the Earth, the green orbit is the moon's orbit around the Earth, and the sun's orbit is the blue orbit, geocentric system. The moon's orbit, which is the green's orbit, is making around 5 degrees inclination to the ecliptic or the sun's orbit around the Earth. As you can see here, a full moon occurs when the moon and sun are on the opposite sides of the Earth, because the sun's rays will then be fully on the side of the moon that is facing the Earth, and that is a full moon. On the full moon day only, the eclipses also occur, because an eclipse occurs when these two axes intersect, so that the sun, the moon and the Earth would then be in the same plane. which will be the plane of the blue circle basically, right? And when that happens and it's a full moon, so the moon, the earth and the sun are in the same line, but the moon is opposite to the sun, but the earth is exactly in between the moon and the sun. That is when an eclipse occurs. So the eclipse occurs at the intersection point of the moon's orbit and the sun's orbit. But at all other points of time, when the moon is somewhere on this green line, green orbit, and it's a full moon, you will see, and it's opposite to the sun, then you will see a full moon. So the moon takes from this point M1 is a point on the position of the moon on the moon's orbit. From M1, when the moon basically does a one revolution and back to M1, it takes 27.3 days. So 27.3 days for one full moon revolution. A same number of days the moon takes to rotate about itself. So the moon is rotating about itself while it revolves around the earth. And the time taken for the moon's rotation is also approximately 27 days. So the moon is basically rotating about itself in 27 days while it is taking the same amount of time to complete one revolution, and that is why we only see the whatever we call as the front face of the moon with the rabbit kind of indentations on it, and we never see the back side of the moon, right? But that's a different thing. Now coming back to the revolution of the moon, from M1 to finish one circle around the moon's orbit, it takes 27.3 days around the earth. But by the time moon has completed one revolution, the sun has moved from S1 to S2 on its own orbit about the earth. It is revolving, right? So now a full moon will not again occur at M1. For that, the moon has to slightly move ahead to M2 so that it is diametrically opposite to the sun as seen from the earth. So if it takes 27 days for moon to go and come back to M1, it takes another 2.2 days with the relative speeds of motion of moon and sun, another 2.2 days for the moon to reach the point M2, which is opposite to the sun, such that the second full moon occurs here. So between M1 and M2, the time is 29.5 days. So 27 days M1 to M1 plus another 2.2 days. So that is what I have mentioned here. 29.5 days it takes from full moon to full moon. So again, in this image, if you see, this is one full moon that is occurring here. The sun is in this zodiac sign and the moon is here, and the lunar months, the solar months, we have understood that, let us say that this was Dhanur Rashi, so the sun, this was Dhanur Maasa when the sun was moving into this zodiac and moving out of this zodiac into Makara Rashi. This is Makara Sankramana, and this is the month of Makara wherein the sun is moving around 30 days in this orbit. Similarly, the lunar month is the month when, as you see the moon, a full moon, so from the earth now you are seeing a full moon because it's opposite to the sun. If you draw a straight line, whichever star is in the backdrop of the moon when it's a full moon day, the lunar month is named based on that. So the lunar month can be either new moon to new moon or full moon to full moon. We consider, let's say, full moon to full moon. Let us say this pink star is Makha, the star Makha, as per the Indian naming. So when this Makha star is seen from the earth on this full moon, that Maasa is called as Magha Maasa. We learnt at the beginning of this video in one of the sections that the 7th day of this Magha Maasa, right, is basically the Radha Saptami. So 8 days before this day wherein this particular star is seen in the backdrop of the full moon, that is Radha Saptami. Okay. Now you have seen that it takes 29.5 days, 27.3 plus 2.2 days approximately for a full moon to a full moon cycle. That is from M1 to M2, M1 back to M1 and to M2, it is 29.5 days. So to complete 12 full moons corresponding to the 12 signs of the zodiac, the moon takes 354 days. So 12 lunar months are completed in a span of 354 days. But you know that the sun takes 365 days and 6 hours and 9 minutes to complete its 12 solar months or revolutions crossing all the 12 zodiacs. So now there is a difference. So imagine that the sun was here to start with, and then after 354 days the moon has completed 12 lunar months, and after 12 full moons the sun is still here at this first black dot. It still needs 11 days to complete its full circle. Okay, after 354 days or after one lunar year the sun is here, it is lagging. After another lunar year, second lunar year, the sun hasn't yet completed its full cycle. So till now let us assume that 12 lunar months and 12 lunar solar months, 12 solar months and 12 lunar months are in sync. Now so the sun is lagging, right? So approximately after around 32.5 lunar months, the sun would be lagging from its starting point here. So after first lunar year, sun lagged to the first. It is lagging the blue line at the black dot. It is here. After the second lunar year, after 12 lunar months, it is here. After around 32.5 lunar months, the sun is approximately at the end of the previous Rashi, right? It is just entering into this. We know that the sun takes around 30 to 31 days to pass from one Rashi to the other Rashi, but the moon, between two full moons, it is 29.5. So what happens here is, now when the sun is here, after 29.5 days, when the next full moon occurs, it so happens that the sun hasn't crossed this into the next Rashi. So as Sankranti hasn't occurred as per the solar calendar. So the sun is moving from the starting of this same Rashi to the end of this same Rashi in 29.5 days between one full moon and the next full moon. So two consecutive full moons can occur without a Sankramana happening or a Sankranti happening or a switch of the sun from one Rashi to other. That is termed as Adhika Maasa. So you have 2 lunar months without the switch to a next solar month. So what they do is they name it as Adhika Maasa. So assume that this is basically your Pisces or Meena Rashi, and the next one is Mesha Rashi. So if the sun moves from the beginning of the Pisces to the end of Pisces without switching into the Mesha Rashi, and you had 2 lunar months, this first black dot and the third black dot, let us consider them as the 2 full moon days, 29.5 days apart. So basically they both are basically considered with 2 full moons are occurring without the sun switching into the next Maasa. So you call from here to here, you call it as Adhika Maasa, right? Adhika Chaitra Maasa, because the next switch is to the Aries, right? The next switch, when the sun moves into Aries, from then on everything is corrected again. The lunar and the solar months both keep switching together. Together means next lunar month would be corresponding to next solar month. So this will be called Nija Chaitra Maasa because the sun has really switched into the Aries. So this Adhika Maasa is basically a correction to account for the lag in the movement of the sun to complete its 12 zodiac, complete its movement around the 12 zodiacs as compared to the moon's movement around the 12 zodiacs. Thank you.